that since we looked at arithmetic sequences and then we looked at arithmetic series, that after we're done looking at geometric sequences, we look at geometric series, which, you guessed it, is the sum of the terms of a geometric sequence. So you have an arithmetic sequence, which is just an arithmetic number pattern. You have an arithmetic series, which is the sum of those numbers. You have a geometric sequence, which is a geometric number pattern, and then we have a geometric series. So we're looking today at finding the sum of a geometric series and determining n in a problem that involves geometric series. What does that mean? It means you're trying to find out how many terms there are. And I want to draw your attention to your formula sheet. Let me pull up a formula sheet here so we can look at it. When you take a look at your formula sheet, and I gave this out in the seminar this morning, so some of you may not have it, and I look at any of these three formulas that we can use for arithmetic sequences and series. If I ask you to find n, it's really easy. Not really easy, but it's doable because the n in all of these formulas is what you would call a linear variable. For example, in this particular formula, if you wanted to get n by itself, you can accomplish that by subtracting things and dividing by things and adding things. For example, I could take Tn, whatever number that is, and subtract T1, and then I could divide that by D, and then I could add 1 to get n. If I take a look at this formula, I guess what I could do is I could take Sn, whatever number that is, and I could multiply it by 2 to get rid of that 2, and then I could divide the result by whatever this is, and I would get n. Actually, a bit of a lie. I don't think you can rearrange that for n. You will be able to by the end of this course. But when we get to geometric and you're trying to find n, we've already talked about this. You do not know how to algebraically find n in this formula here because the n is part of an exponent. So how are we finding n? You were going to your calculator, weren't you? You're putting in the expression for Tn, going to your tables and finding n. And that's going to be the case with geometric series as well. So there's not a lot of algebra here. The algebra would be something you would spend a lot more time on in Math 30 with those types of equations. So let's get started here. A geometric series is simply the sum of the terms of a geometric sequence. So I don't think I would ever ask you this, but a sequence is just the items. Series is the sum of the items, right? So if it's a geometric series, then it's the sum of the geometric sequence terms. As an illustration, if 2, 4, 8, 16, etc. is a geometric sequence, and it is, shouldn't have to look at that very long to see that there's a common ratio of 2. In agreement on that? Then the corresponding geometric series would be the sum of those, which is 2 plus 4 plus 8, etc. I hope you remember our discussion of where this formula comes from. Leonard Euler in, I don't know what grade, 3 or 4 or 2 or 3, it doesn't matter. He came up with this formula and I showed the derivation to you. Actually, I believe it was this formula. And I showed the derivation to you and I explained the logic behind getting the formula by writing the list of numbers out twice but reversing the second time. And you can go back and look at that. It made sense, okay, for the sum of n terms. And the second formula, the one below this one that I've highlighted, we also derived that simply by putting this that in there. There was nothing difficult. At the level we are at in your high school math career, you could understand that. I'm not even going to begin to attempt to explain where this comes from, okay? I wouldn't even know where to begin. And that isn't an insult to you, it's just very complicated, okay? What does this say? First of all, I need you to note that in the brackets here, we have r to the n minus 1, okay? And I'm going to write down the general term formula for a geometric sequence that we learned about last week. The general term formula is Tn equals T1 multiplied by r, which I like to have in brackets, to the n minus 1. And I think this is absolutely crucial that you understand the difference between what I've highlighted in blue and what I'm highlighting in yellow. First of all, let me verbalize it to you. What I've highlighted in blue is this: r to the n minus 1. What I've highlighted in yellow is r to the n minus 1. The exponent on what I've highlighted in yellow is n minus 1. R is raised to the n minus 1. It's raised to the whole thing. What's in blue, r is not raised to the n minus 1. R is raised to the n, and then 1 is subtracted from it. There's a big difference there. And if you don't understand that, it won't make sense. All this is saying is if you want to find the sum of a certain number of terms of a geometric series, put the first term here, put the common ratio here and here, and the number of terms you're adding, and the formula works. We don't need to worry about why. So, let's do a few examples. What's the sum of the first 13 terms of this series? Well, the first thing is appreciating what I've said again and again and again. I've mostly said it about arithmetic. If you know the first term and the common difference of an arithmetic sequence, you can find anything. Well, for geometric, if you know the first term and the common ratio, you can find anything. So I would like everybody to write down for me. I think this is pretty basic, but you've been away for 5 days, so what the first term and the common ratio are. Well, the first term is, it's the first term. I don't know how else to explain it. It's the first number in the list, which is 6. And the common ratio is what you multiply the 6 by to get the 12, and the 12 by to get the 24, which would be 2. I hope, everybody, that nobody needs to do the following to find r. I really hope nobody needs to do this. But you never know. R can be found by taking the second term divided by the first term. What I mean, by the way, when I say I hope nobody needs to do that is I hope nobody needs to do that in this example. Okay? You might need to do it for if the numbers are less obvious. Are we okay that T1 is 6 and R is 2? No problem. Okay. So we also want to find S13, which means that we also know we have to use n equals 13. It's right there. S sub n is S sub 13. So what is our formula? Our formula is Sn equals the first term times r to the n, then minus 1. Look at how I really spaced that out. R to the n, then minus 1. It's very easy to put that 1 where it doesn't belong over just r minus 1. So we can put in all of the numbers. S13 equals T1, which is 6, times 2 to the 13, common ratio raised to n, then minus 1, over 2 minus 1. And I would like everybody to use your calculator to determine the value of that sum. And I'm just asking you to do that because this is just a matter now of making sure that you do know how to use your calculator. I'm old school, as they say. I mean, we certainly didn't have graphing calculators when I was in school. Some of the fancier calculators did have a display screen where you could enter all kinds of stuff and it would keep track of it, but most of them were just, you do it in steps. I would actually probably, if I were in school back then and I had this problem, I would go 2 to the 13 equals, and then I would go minus 1, and then I would multiply by 6, and then I would look at the denominator of this expression and understand that it's a waste of my time to continue because 2 minus 1 is 1, so when I divide by 1, you're going to get the same number. So the answer to the question is 49,146. I like to put commas rather than just spaces. If you're going to do this all in one shot, then I guess you could go 6 brackets, 2 raised to the 13 minus 1. If it were 2 raised to the n minus 1, like in the general term, then I would need brackets around the 13 and the 1. But I don't do that here because my calculator knows order of operation says I raise it to the 13 first, then I subtract 1. Close brackets. I don't need to continue here again because I'm dividing by 2 minus 1, but if you, which is 1, but if you did say divided by and you put 2 minus 1, then you're going to get an error. Well, you're not getting an error. You'll get the wrong answer. What's wrong with entering that? I'll even show you. It's not going to give you 49,146. Thomas, what did it do?
You divide by 2 first, then you subtract.
Right. What I just entered was... Oh, there it is. Oh, my computer's really slow. This thing that I've just entered is 6 times 2 to the 13 minus 1 divided by 2 minus 1. That's what I've entered. So it's not always going to be the case that you're dividing by 2 minus 1, and you can ignore that. If you do need to do it in one shot, then you would have to put r minus 1 in brackets after the division sign. This little 3 or 4 minute discussion here is just about making sure you know how to use your calculator, that's all. I don't know if you recall, but I told you that we could all become rich, or you could all become rich, or actually I could become rich, and you could all get 100%. Remember that discussion? I think I said March, starting in March. January, February, March has 31 days. So day 1 was a penny. I'm going to write that as $0.01. That was the first day. Second day was $0.02. Third day was $0.04. And I don't know if you remember, but on the 31st day, I think it was something like $10.7 million. If I said, how much money am I going to get from you in total, then rather than just finding, oh, by the way, let's do that. If I said, what is T31? Do you remember me standing here going equals, 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 equals on the calculator? Well, I could just take the first term, which is 0.01, times the common ratio, which is 2, to the n minus 1. This is the general term. This is not a sum. This will find out how much money I get on the 31st day of March from you. Well, in my dreams. But this should give us that what I think was $10.7 million. 0.01 times 2 raised to the 30. Right? 31 minus 1. Yeah, there's that $10.7 million. If I said to you, okay, calculate the total, imagine having to add all those numbers together, you could do this instead. The first term multiplied by the common ratio to the n, then minus 1, over the common ratio minus 1. Well, we're getting lucky with the 2 minus 1 thing on the bottom. Again, it's not always going to be that way. So what would this be? This is a total. 2 raised to the 31 minus 1 times 0.01. Looks like about $21.5 million roughly. Put your phone away, please. Number 2, find the sum of this series. Is this the same one? No, it isn't, eh? Is this your number 2? Okay. Find the sum of this series, so 6 plus 12 plus 24, etc. Okay, so the first term is 6. The common ratio is 2. In fact, it is the same sequence, isn't it? It's just that we're only adding up to 384. I want everybody to give some thought to this question as it stands right now and figure out what it is that we're missing. I don't want you to figure out the value of what we're missing, but what are we missing here that's preventing us from finding the sum of the terms? Yeah. Right, we don't know how many terms we're adding, right? In the last one it said find S13. So we don't know n. But this goes back to day 1 of this unit. It goes back to a question that you had on the quiz on day 2. If you can figure out the value of n that gives 384, then you will figure out how many terms there are, because that value of n is the term number of 384, and it's the last term. 384 is the last term. So that's what we have to do. We have to go to our formula sheet and go to our geometric general term formula and use this to determine what the value of n is that would give us 384. So we have to just take a detour here. The detour is using Tn equals T1 times r to the n minus 1. We could develop this formula first by putting in 6 and 2. But ultimately what we want to know is what value of n is going to spit out the number 384. That's what we need to know. We could just guess and check. We could fumble around in the dark and pick a value of n like 7 and see if it works. Or we could be a little more crafty about it and in our calculator put 6 times 2 raised to, in brackets, x minus 1, and go take a peek in our table to determine the value of x that gives 384. Now, you know, this may happen to you from time to time. You go to your table and it's in disarray. It's all over the place. That's because I haven't got it set to be on automatic. I was doing some other things with it. Second window takes me to table setup. Let's start at 1 and go up by 1 automatically. So this generates T1, T2, T3, etc. Go to my table now. Oh, that makes more sense. Oh, they're 384. 7. Did I guess 7? By the way, I did. Wow. It's not a stroke of genius. It was just fluke. Okay, it was just a number that popped into my head. So what we've done now, and this is what I was talking about earlier, we have not algebraically rearranged that for n. You don't know how to do that. We've just used our calculator. We've said, okay, you know what? This is the 7th term, which means we're trying to find S7. And now we can calculate it. We can use our our summation formula, which is Sn is the first term times r to the n minus 1 over r minus 1. And even how I said that, I feel a little bad in how I said that. I said times r to the n minus 1. It's times r to the n minus 1. We can put in the numbers. This question, in fact, is no different than the previous question, except that we're using 7 instead of what I think was 13. First term is 6, the common ratio is 2. And we'll calculate what that is. By my count, it's 762. All right. So now I want to draw your attention to finding the sum of the terms in a series. And I want to go back to arithmetic. When you look at the two formulas to find the sum of the terms of an arithmetic series, it doesn't matter how you cut it, you need to know how many terms you're adding. You have to. Mathematically, there is no formula in the universe that can calculate the sum of the terms in an arithmetic series unless you tell it how many terms. But there is a second formula for the sum of the terms of a geometric. And surprisingly, it's really interesting. I wish I could show you the derivation because it has n in it and you go through all this complicated math and then at the very end, the n's cancel. And you don't need to know how many terms there are. I hope you remember that when we were finding sums of arithmetic sequences or series, we had to take that detour quite often, didn't we? To find the last term's number, to find out how many terms there are. Here you don't. In this formula, Sn is r times Tn, which is the last term, then minus the first term over r minus 1. So let's go back and for question 3, let's do number 2 again using that formula. Let me write the formula down so you can see it. Sn equals Rtn minus T1 over r minus 1. Here's example 2. And I asked this question, what are we missing? And it was pointed out that we're missing the number of terms. But you don't need the number of terms with this formula. Which is really, I think, kind of a weird thing. We don't have to know how many terms there are. All I have to do, I don't even know what n is. I can't put in a number for n. I just go Sn equals the ratio times the last term. I mean, you do need to know the last term. Minus the first term over the common ratio minus 1. So let's confirm that we get the same answer. Was it 762? Is that what we got? It was. Okay. Oh, yeah, it's right there on my calculator. So 2 times 384 minus 6. Well, that's a mathematical miracle. You get 762. Which is a really nice thing about geometric series, that you don't need to know the number of terms. We okay with example 3? So now just to summarize here, you have these 6 formulas that you're aware of. Now, I do understand there's another one below this on your formula sheet, but it doesn't apply to what we're dealing with today. It will apply to things we deal with tomorrow. I haven't quite got all of your names yet, but Carell, right? Okay, so there's the assignment and there's the formula sheet. Zoe is not here. Jasmine is not here. Declan is not here, right? Okay. Oh, just got a bunch of people out sick today, I guess. Lily. So here, Lily, is the assignment that's due Wednesday and a formula sheet. Adriel is not here. Grace, right? Okay. Is there anybody else who is here now that wasn't here this morning that I did not just give something to? Or did I get everybody? Okay, good. So what you have now comes the part of the course where sometimes this confuses a lot of people because there's so many formulas. It's not a problem for me and it's not a problem for most people. Some people look at this and all they see is just a bunch of marks on paper, right? We don't always see things the same way. So you have a general term for arithmetic, a general term for geometric. You have two formulas for arithmetic series, and you have two formulas for geometric series. Now it becomes a matter of me not saying to you, particularly for the exam on Friday, find the sum of the following arithmetic series. I'll just say find the sum of the series, and you have to decide whether it's arithmetic or geometric and go from there. Anyway, you have all of those formulas at your disposal now. You can see some other things that we're going to be dealing with throughout the semester. Number 4, if a series is this, then how many terms do you have to add to get 6,560? Well, you know what? From a standpoint of a problem-solving approach, this is pretty easy because, well, first of all, let me back up. Is this arithmetic or geometric? Geometric, isn't it? Multiplying by 3 regularly, so there's a common ratio. So we're going to have to use, since it talks about a sum, we're going to have to use one of these two formulas. But since the question asks how many terms are there, the only formula you can use is this one because the other formula doesn't have n in it. So we have to use this formula, Sn equals the first term times the common ratio to the n, then minus 1, over the common ratio minus 1. If we put in everything we know, the first term is 2, the common ratio is 3, and the sum, even though we don't know how many terms there are, the sum is 6,560. So what we get here, we'll get 6,560 equals 2 times 3 to the n minus 1. And look again how I separate that minus 1. Like it's minus 1. It's way over there. Over 3 minus 1. Probably shouldn't come as a big surprise to you that you do not know how to rearrange that, since the variable you're trying to find is in the exponent. What you are going to do is put this in for y1 and go table exploring and find out where that thing equals 6,560. So 2 brackets 3 raised to the x minus 1, n bracket divided by 2. I don't think, so the calculator knows 3 raised to the x minus 1 as I've typed it in means 3 raised to the x, then minus 1. I don't think we really need to put divided by brackets 3 minus 1. 3 minus 1 is 2. So I've simply said that this thing is 2, which, you know, now looking at it, I probably would have just entered this because this 2 and this 2 cancel, but we could have simplified it a little bit. Won't worry about that though. Now we go to our table. How many of you see that we could have just entered the 3 to the n minus 1? There's 2 that cancels there. Pretty basic stuff. These are not term numbers, these are sums. There it is, 6,560, so there are 8 terms that you're adding. These are certainly not written response questions that I would give you, they're numerical response questions. Any questions with number 4? All right. For 5, a geometric series has 5 terms and the common ratio is negative 3. The sum is 10,940. What's the first term? This is all just about using formulas. We can use this formula, Sn equals T1 times r to the n minus 1 over r minus 1. Let me highlight for everybody what it is we're trying to find. You're trying to find this. Since that is not part of an exponent, you don't do it using your tables. You need to know how to do this on paper. The sum is 10,940. We don't know the first term. Then we have r to the n, which is negative 3 raised to the 5 because there are 5 terms. And that negative 3 needs to be in brackets. And I realize that some of you are going to say, I'll get the same answer. I'll get the right answer whether I put it in brackets or not. And that's true, but it's only true because the exponent happens to be an odd number. If that exponent were even, it wouldn't work. So my recommendation is, particularly when you have negative bases, put the base in brackets. Then minus 1 over negative 3 minus 1. Now, as you have probably discovered, sometimes I'm not a traditional kind of math teacher. I make up words or I approach things differently. This is how I learned math. I want you to recognize something that this, maybe I'll use a different color, that this thing is just a number. Forget about what the number is. Negative 3 to the 5 minus 1 is a number. It's just a number. And this thing, which isn't difficult to figure out, is just a number as well. It's a different number. So how would you rearrange this to find the first term? Well, you got to get rid of 2 numbers, don't you? How do we get rid of the yellow number? You divide both sides by it. How do you get rid of the green number? You multiply both sides by it. You don't have to make this really complicated. They're just numbers. So let's figure out what those 2 numbers are first. By the way, we could divide them first and then just divide. But negative 3 to the 5 minus 1, I believe, is negative 244, but I need some help with that. Okay. Just in case, I mean, I know it's right now because it's been confirmed, but just to show this to people, negative 3 in brackets raised to the 5, then minus 1. You get negative 244. So we have 10,940 equals the first term times negative 244 over negative 4. So, you know, I guess I kind of take it back. We could do it the way I said. To get rid of the negative 244, you'd have to divide by negative 244. Okay, let's try that. $10,940 divided by negative 244 is this, and then we would have to multiply by negative 4 to get rid of the negative 4 on the bottom. So this is the first term. Okay. We are not worried here about getting it as an exact value in fractional form on paper. But if your calculator can handle it, and we go math, enter, enter, that's the answer. Okay. How many of you, when you do that on your calculator doesn't give you that fraction, just gives you the decimal? Couple. We could have seen that's the answer by doing the following. Right now, I am in a general numerical math instruction mode. I'm not talking about sequences and series. I'm talking about numbers. Can you divide negative 244 by negative 4 without decimals and remainders? Try it. Probably not going to be a surprise that you get 61, which explains why T1 is 10,940 over 61. Any questions with number 5? That's it? That's it? Was that the last example? Pretty light day. You got over a half an hour here. So use your time wisely. You should be able to get a good chunk of this practice done, and then you can also work on that written response problem. Tomorrow we have one more lesson. You're going to have an assigned practice section tomorrow. This assignment's due the day after tomorrow. So as you don't wake up in a cold sweat in the middle of the night on Tuesday night after you go to sleep and go, oh, I forgot about that assignment. Make sure you get it done early. Okay, it's very easy to forget about those things. Give me a second to trim my video and get a couple things taken care of, and then I'll come around and I'll give you a hand.